Welcome to episode 3 of Building AI Agents to play Leisure Suit Larry, a classic adventure game. Today we're going to talk about the challenges in this project, of which there are many. So let's start by going through them, and then we'll take on one of those challenges today, and we'll pick up some of the others in future videos. Let's start with the first issue, which is object detection. Now this is a problem because the tools that we're using, which are Grok and OpenAI and so on, they often do have object detection in the platform, but that object detection is only good at sort of saying that a specific object is in an image and it's in a certain area, like maybe the top right, something like that. But it's not good at giving pixel accurate data back on where an object is. Another issue is path navigation. That's basically the AI plotting a course for the character to move through the pseudo 3D world. Most images are forced perspective. You can walk behind things. At this time, I'm not giving the AI any more information than what you can see as a user, and so it's got to be able to figure out when and where it can walk behind things and so on. Another issue is task management, that is quest identification, keeping track of the status of quests, task maturity, so staying on task. If you try to look at the door and then it says that you're not close enough, and then you get closer to the door and you then instead go on to look at something else instead of trying to again look at the door or open the door or something like that, that's bad task maturity. And then there's also task hierarchy. Understanding that you need to complete one task before you can complete other tasks or figure out the overarching task of the game. Another category of problems are common LLM problems. They are things like hallucinations. You see things in the scene that don't exist. Context rot. So the more information we provide in the context, the worse the LLM becomes at predicting good answers. I also see it ignoring instructions. And another issue, which is sort of unrelated, but it's a problem to solve, is slow responses. So if a response is going to take 20 seconds, then, for example, we're forced to pause and unpause the game and do things like that, and it's not like a natural user playing. So we really need to get down to, a second or a few seconds to be much more like a real user playing. There's also adventure game stumpers. These are things like maze puzzles. So think the root monster in Space Quest 2, or you can think of Roberta's Stairs or other maze style quests. Another one is pixel hunts, where a single pixel on the screen means something. It's very unlikely that the AI is going to pick that up. And then moon logic puzzles are also a big problem, because if the puzzle really doesn't make a lot of sense, or you have to make a big leap to make that puzzle work, it's just super unlikely that the AI is going to figure that out. And then there are two classes of development issues I want to talk about. The first is that even developing the agent is costly. When the agent goes out and loops on the same tasks or struggles to make progress, you have to let it do that because you need to try and learn and figure out what it's doing. That costs money. So I've spent hundreds of dollars on this project, and it's one of the only side projects in programming where I've spent money, and that's fine, but it does have a real cost. And then the other challenge is testing. So if I change the prompt instructions or I change the structure of the context, then how do I really test that these are all around better changes? And how do I know that I haven't messed something up? Right now, I have to let the AI go through a bunch of scenarios, and I have to decide qualitatively by watching. And there's no really good metrics to know that I haven't made any major mistakes. Test harness. That is our list of challenges, or at least the ones that I've run into so far. Now let's jump into tackling the first one, which is the object identification and getting those bounding boxes and getting them tighter. So as I mentioned, the reason why this stinks right now is that the AIs are not specialized at this. They can describe the image to you, or they can be used to write a description of the image for alt text on a web page or something like that, but they're not specialized enough to give you really good bounding boxes. They also take a lot of time in order to analyze pictures. So when it comes to the bounding boxes, we can either call an external service with a specialized machine learning platform to do that, or we can do something else. And I've chosen, for cost reasons and also just for time reasons, to do something else. These images are 320 pixels by 200 pixels and are guaranteed to use the 16 colors from the 16 color EGA palette, and the only wild card is dithering. So my thought is to really just do some additional pixel analysis and do that as a tool. So what I'm doing is I use the LLM to identify its bounding box area. It gives back a general area for the bounding box. Sometimes it's close, sometimes it's not close, sometimes it's too small, sometimes it's too big, sometimes it has the wrong color, but usually it has the right color. So we get back a bounding box and a color. And then I use that dominant color in that area to then do the pixel analysis, and I tighten up the bounding box. The reason why the bounding boxes are so important is because we're using those bounding boxes to help drive navigation and object avoidance. So they're going to become even more important later as we tackle that problem more specifically. You can see here with the simple tools that I wrote, which is really a simple process of using a sort of confidence value and looking at the pixels around the given bounding box for clusters of the dominant color that I get back, and then setting a really tight bounding box once I find that cluster. And that strategy works pretty well, so we're going to stick with that until we need something better. So that's our first problem solved. In our next video, we're going to get into the context and context rot, and that's the challenge that we'll look at, and we'll see if we can make really good progress on that problem as well. Thanks for watching.